condition when cathode terminal voltage at the cathode terminal would be more than the anode terminal. And when this situation will occur, when this terminal will have positive voltage. When this terminal will have positive voltage during the negative cycle of the input. So during the negative cycle of the input, this terminal, this cathode will have positive potential. Okay. So you see that it is a sinusoidal signal, alternating signal. So for the first half cycle, this is positive and this is negative, and the next half cycle, this is negative, this is positive. So this way it is changing. So when the input voltage becomes negative, that time this cathode terminal will have positive voltage appearing on it. So we see, and that time it will be forward biased and the diode will be on. Okay, and when it will be on, this is the this is VO. Yes, sorry, this is actually V output voltage. Okay, so when it is on, that time we get output voltage VO equal to the diode voltage drop. If it is 0.2, then 0.2 voltage, but negative. Okay, so so here it is drawn here. You see that during the negative cycle, okay, when become input voltage becomes more than 0.2 in the negative direction. Okay, that time diode becomes on, and immediately it will be output will be, since it is now that time it is shorted. Okay, like it is shorted path. Okay, shorted path, but voltage, it has certain voltage as 0.2 volt. Okay, 0.2 volt. This is according to the polarity, this will be minus 0.2 because we are measuring from this terminal. This is, we are assuming positive, but it is actually negative. Okay. So this is now on, and when the input voltage becomes uh, higher than minus 0.2, let us say, or in this case, if the input voltage is positive, okay, that time this diode will be open circuited like this. So here will happen V0 will be equal to Vi, and in this case Vi is less than V gamma. Okay. That is minus 0.2. Minus 0.2 से अगर कम है, that time it will be on, and in this case Vi is greater than minus 0.2. So it will be off, and from that point the circuit will remain open, and you will see the whole input voltage will appear across the output. Okay. Now what happens? Next case is what happens if you add one reference voltage to this circuit. So in this case, at what condition the diode will be on? Can anybody tell?
Sir, if VR is greater than VI.
If
VR is greater than VI.
And considering the cut-in voltage,
Sorry, sir. VR should be greater than VI plus I into R.
so you don't know about the current, amount of current. You have to consider the diode voltage, that is diode cut-in voltage. Diode cut-in voltage is V gamma. Okay. So diode say how it is the what is the polarity? Diode cut-in voltage polarity is this is V gamma. So this is plus and this is minus. This is V gamma. Okay. So VR and VR, it is series opposition. Series opposition. Okay. So VR minus V gamma is the voltage below which if the input falls, then it will conduct current. The diode will be on. So यहाँ पे जो voltage आ रहा है, okay, यहाँ पे जो voltage आ रहा है, it should be voltage at this point should be lesser than VR minus V gamma. VR minus V gamma. So anode voltage here at this point should be more than the cathode voltage that time. So here I have written, you see, that when VR is VR less than VR minus V gamma, so VO is equal to, so that time what is the output? Our output will be clipped at this amount, VR minus V gamma, that is this value. But it is not actually a straight line. It is looking like it's a attenuated graph. Okay. So here for but if say actually VR is far higher than V gamma. Okay. So you can ignore also this V gamma value, but actually if you want to know the exact value, then you have to consider the value of V gamma. Now you see the transfer characteristics here. It is the opposite way, that when in this point is VR minus V gamma. Okay, input voltage increases from 0 volt to any value. But at certain time, the input voltage will be, say, when input voltage is less than VR minus V gamma, that time the diode is conducting. Okay. Say for this part, diode is conducting. But when input voltage is greater than this, then diode will be off. Okay. Diode will be off. So if the diode is off, then whole output will be equal to input. Okay. So slope is 1. So that time slope is 1. And here when the diode is on, that time slope is RF by RF plus R. Okay. So so if you draw the transfer characteristics and each and every points, if you map each and every points of the input, okay, you just map on the transfer characteristics, and from there you draw the output characteristics. So actually the way is for this point is this one. Okay. Then this point is this one. Okay. This point is this one. And after that, the input, the diode will be off. So output will appear at the input. And before that, there is attenuation. As the diode resistance changes, voltage across the diode or output voltage changes. So this is one example. Now for more example we will see here. Now uh, another condition is that when diode is reverse biased, that time it has very high resistance, but we don't consider it. We assume that is very high, so we ignore it. But if you still consider, if you consider the reverse bias resistance, say that is RR, okay, reverse bias resistance, and this is forward bias resistance. This is forward bias resistance, that is reverse biased. So if you consider this RR, then uh, it will be more accurate for analysis. So in that case, transfer characteristics will be modified, okay, and it will have the slope of RR by RR plus R. And in the previous case, when the diode is forward biased, the slope is RF by RF plus R. But in reverse bias case, if for some diodes when the current increases with reverse bias voltage, reverse currents increases with reverse bias voltage, so that time it is having some linear range, linear operation, linear curve. So it will have some slope of R by RR plus R. Okay. So if that is the case, then generally the resistance we use series resistance that R. So this reverse bias resistance may be some multiples of R, okay, some orders of R very high. So RR is very much higher than R. So let us say we use some constant K, okay, so that is K times R, say, for example. And similarly, since the forward bias resistance is small, okay, so in that case the resistance that we choose R, say it is K times RF. It is very small and this one is very large. So what value of resistance we should choose? So you can have an idea by seeing the reverse and forward resistance of diode. So that is the calculation done here, that we can choose the value of resistance R for the clipper circuit. It should be root over of RF into RR. That is geometrical mean. So it is reasonable to select R as the geometrical mean of RF and R. Okay. So this is another issue, that what value you should choose in the diode resist for the resistance that is used for clipper circuit. Okay. Then there, now we are talking about some clipping circuits. Okay, we just listen it carefully, that there are four types of clipping circuit: positive shunt clipper, negative shunt clipper, negative series clipper, and positive series clipper. All these circuits uses a single diode. There are other types of circuit design, clipper circuits, where we can use more than one diodes, one or two or three, whatever it is. But these are the most basic uh, clipper circuits. So positive shunt clipper, negative shunt clipper, negative series, and positive series clipper. So, and the name you can see, the first we discuss, draw here, that positive shunt clipper. Positive means the if the input signal is sine wave, a sinusoidal signal, it has both positive part and negative part. So if we clip the positive part, means if you remove the just erasing the positive part of the signal, then it will be called positive clipper. And it is shunt clipper if the diode is in shunt position. Shunt across the output means in parallel. That means we take the means it is in parallel with input voltage kind of thing, you can say, or we take the output across the diode. Okay, so and this is biased. Biased means we have connected one voltage, reference voltage VR. We may not use this reference voltage, but some practical purpose we may use this reference voltage. So that is actually that defines that at what level you want to clip the input signal. If you don't use, then it will clip at the voltage level equal to the cut-in voltage. But if you mention it, if you use this reference voltage, it will define at what threshold reference voltage level it will be cut or clipped. So that is the reason why you choose VR. Okay. So then what is the operation? The first waveform, you see this waveform, that you have to look that at what conditions diode will become on. Can anybody tell for this circuit at what conditions diode will become on? This has cut-in voltage V gamma. This is the polarity cut-in voltage. At what conditions it will be on?
So when Vi minus Vr is greater than V gamma.
Yes, Vi minus Vr is greater than V gamma. Correct, very good. And that means when Vi is greater than Vr plus V gamma. The same thing? Is it same?
Yes, sir.
Okay. So here I have written that if input voltage is greater than Vr plus V gamma, or you have told that Vi is Vi minus Vr is greater than V gamma. Same thing. Both are same. Okay. So diode in that case, diode is on. So if that diode is on, that time what voltage at the output we get? We get it is a short circuit path. Okay, simply if you draw it here, okay, it is resistance, then short circuit path, then VR along with some voltage. Okay, voltage of V gamma. Okay. So it is output equal to V gamma plus VR. So we get clipped output at this point. But when input voltage, the opposite is true, that when input voltage is uh, lesser than that, okay, so otherwise, so you can write otherwise, the diode is off. Okay, so that means when input voltage is less than that, less than VR means this portion, this portion. Okay, so we can write here, say here diode is, say diode is on, and here in this region and also this region diode is off. So when diode is off, that time what is the response? What is the equivalent circuit? It is diode on. Diode on. Okay. And when it is this one, that input voltage is lesser than, more than that. Input voltage is lesser than that level. It is totally open circuit. So here diode is off. So V naught is equal to Vi that time. V naught is equal to Vi mean whole input voltage. This is the dotted line is the input. Okay. Both the thing is drawn here, both input and output. So this bold line is actually the output which follows the input. Okay. So that means Vi is equal to Vi. So this is okay. Then negative slant clipper. नेगेटिव स्लांट क्लिपर में क्या हो रहा है, जस्ट डायोड का हम उल्टा कर देंगे. So at what conditions diode will remain on? Can anybody tell?
So when VR minus VI is greater than cutting voltage.
Vi minus VR is greater than cut-in. This you are telling?
No sir, VR minus VI.
Okay, VR. Okay. Yes, that means this is VR and okay, so this is VR minus VI, correct? VR minus VI. So that means VI, if you write in terms of this is VI is VR minus V gamma, isn't it? So diode is on. Diode is on when input voltage, let us say oppositely, when input voltage Vi is less than VR minus V gamma. So is it working then? Say
the battery will be inverted in this case. Battery. Look at the battery.
Yes.
No, battery.
Yes. Yeah. Battery. So
battery becomes minus plus. VR becomes minus. You have to make VR equal to minus here, not plus.
So you know the variation.
Okay, so but here actually
the battery inverted. Otherwise,
whatever the waveform, okay, waveform is that is it correct? This waveform.
This will also be VR plus V gamma only, but negative sign. This will also be VR plus V gamma, but with negative sign.
Yes.
Clipping in the positive direction will be having something different one. That there only I got stuck, and I will start my lecture from that point.
Okay.
Here if you come, will be a different characteristic.
Here actually.
Here is my negative, battery negative here. Then you are right. Negative direction clipping.
Input agar VR
is negative, yeah.
VR minus.
Battery is inverted.
Let once, sir. Input agar is.
Anode becomes negative. Cathode becomes positive.
No, input agar if diode is on, then
this is not the.
So this is actually this time it is clipped. Okay, so it is actually clipped.
Okay, you're clipping it. Okay, okay. Positive. Okay,
Yes,
peak of the positive cycle you are clipping. Okay, fine. Understood.
yes, yes.
Okay,
Clipped.
okay, okay. It's
Only
okay.
the positive side will be transmitted.
Okay, okay, okay. Fine,
This is
fine, fine. It's okay now.
yes, yes. So diode is on when this is the condition, and you see, and when it is the opposite, that for negative portion, it will be input. Uh, so for the positive portions will be here. Then you see that if VR is not present, this VR is not present, that time what is the output? We see that output slightly dips to some negative value, or that is exactly equal to the V gamma. Okay, so that is minus point, we can say. So if VR is not present, okay. So this is, and also in the previous case, here I forgot to discuss that when in this VI during the, if VR is not present, so in that case the positive portion, it is clipped to not 0 volt exactly, it is actually clipped to V gamma. Okay, this portion, if VR is not present. Similarly here in this case, it is clipped to minus V gamma. Okay, if VR is 0. So this thing you see. Then another condition is that diode is series with input voltage. So it is called negative series clipper, and it is also biased. So in this case, the diode will be on, okay, when here it is written that when Vi minus Vr is greater than V gamma. Vi minus Vr is greater than V gamma. So that time it is on, and here it is slightly different, the operation, that if the output is generated due to the voltage drop, okay, voltage drop across resistance, and that time output is equal to input. Okay, here you have seen that Va is equal to, no, sorry, during on operation, you get the output. Okay, when Vi is greater than, yes, when Vi is greater than Vr plus V gamma, here also V gamma is there. When Vi is greater than Vr plus V gamma, that time diode is on, and we get the output voltage due to the voltage drop across resistance, or you can say V0 is equal to Vi, okay, or it is the
Start with the matrix method.
voltage drop,
Again, they do not come back.
voltage drop, okay, across resistance, across R. And when input voltage Vi is opposite to, that is less than that value, Vr plus V gamma, it is clipped to, okay, it is that time it is diode is off. Okay, when it is, so let me draw that in on condition. Okay, in on condition, this is the circuit. Okay, diode on, and in off condition, so that time V0 is equal to Vi. Okay, and when diode is off, that time we get this voltage output. Okay, diode is off. So we get the output, okay, that is clip to VR, this one. But situation comes, if VR is equal to 0, then what happens? If VR is equal to 0. So if VR is equal to 0, that time it is a simple rectifier circuit. Okay, simple half wave rectifier, and you know that ये on जब रहेगा, diode, if when the diode remain on, that time, okay, so it will reduce the input voltage by V gamma amount. So input voltage voltage will be V peak minus V gamma in this case. But this voltage is 0 volt. It will lie on the axis. It will not go down the axis. It will not, there will not be any dip. It will lie on the axis. This one. But peak voltage will be go to V peak minus V gamma. So then another condition is positive series keeper. Okay. So here positive portion is erased. So that's why it is called positive portion series keeper. So in that case, here you see that when input voltage Vi is less than Vr minus V gamma, diode is on, and similarly when it is on, so we get the current flow, okay, and we get the voltage drop. Okay, V0 is equal to Vi due to current voltage drop due to current flow. Okay. And the opposite other case, that is when diode is off, that time it is clipped. It is clipped to Vr minus V gamma. Okay. So these are the two cases. Now another circuit for clipping is using two diodes. Okay. So next time I think it will be better if you discuss in the next class. Is the time is over, I think. Okay. Because it will another, after this another small topic will be there. So I don't want to discuss it now. I'll discuss in the next class, and by the time you just go through this study material that I'll upload. Okay. Okay. Answer.
Any question you can ask?
At two independent levels means two diodes will be there in opposite direction.
But not the two peaks of the sinusoidal signal. Two peaks of sinusoidal signal.
Not two peaks. Not two peaks.
Not two peaks.
I just showing this one.
Intermediate values you are choosing.
Yes,
by clipping the two. That is there.
This one and this one.
Okay, because I will explain to them what way the peaks can be clipped like that, and there I think you can say multiple value, dual value of the signal at one time, that should be avoided. Until I do that, I cannot do the clipping at the two things. As I will explain to them later on. So next time you will be first 15 minutes you try to summarize that. Clipper, one side clamper will come again like that, but clipper will finish on next class. At the most one more lecture you can take on the Monday, and at the most Wednesday we can take on the clipper circuit.
Yes.
Okay, students, any question here? So diode characteristics you already know.
Okay,
no question. Okay. Because we'll be putting.
Actually, a lot of people remain absent. I think because we have to take the attendance. Otherwise, they are.
Attendance different sections are supposed to take section in charge. Different center in charge are supposed to take attendance.
Yes.
That is there because I find less than 50% are coming, and the result is very bad. I think they will be the sufferer. They are not realizing that is a conceptual thing. In the quiz one itself, I don't think they encouraging remarks. You can check them and let me know how many percentage of people have gone. They have crossed 50% threshold or so. Out of 10, more than 5, how many have got? Because if they're not coming, those mistakes will be. I have uploaded the solutions. You can check the solution, get your doubts clarified. If something is there, you can put the questions to me in the next class. Okay. Thank you, Professor Gupta. You have done a very good job, and you have done the analysis, etc.
Yes.
Excuse me, sir. Sir,
Yes.
of this module, some questions, can you upload some questions so that we can practice? Or
That's what we are teaching all questions only. Sometimes diode resistance will be there, sometimes diode resistance will not be there. Sometimes your input will be sinusoidal, sometimes your input can be square wave also. What will be the output in that case? Will the amplitude get reduced or not? So these are the things, I mean, these are all part of the numericals only we are talking in the clippers.
okay, sir.
So I'll be taking some more example. Well,
Yes,
variety of resistances will come into picture. And as I said, the dual value, two value of two valued signal that you have to avoid when you're going for selecting only the positive peak and negative peak. In between I want to drop. So if you make a composite circuit, one single one using two diodes, you will be in trouble because at one time it will be having two values. So you have to avoid that. That cannot be realized. Two valued output cannot be realized. So these things I will explain to you, and that will be a numerical problem. Also, same thing. I'll put the numerical value. You will have to calculate that. That will be a numerical problem. Okay.
Okay. Okay, sir.
RF, R, all these things. Diodes V gamma will be put into picture like that. In some of the books, they take QV divided by KT as your V gamma, something like that. Q divided by KT, they take as V gamma, something. So those things will be, I mean, putting as a numerical there. Okay? Fine. So, I mean, all are numerical one to okay. You bring your question that way, take any numerical, calculate. If you're getting stuck somewhere, sir, this is the thing I have got, this is the output according to my calculation, is it correct or wrong? We'll comment on that. Okay? Do that.